So you should just be returning from watching a video on modeling addition problems with the, I'm calling them here, red and blue chips. You were using red and yellow chips. So I hope you took any notes that you needed in this region. Probably you didn't find it terribly difficult to understand. Now, if we were really in class, we would play this dice game. Okay, so you'd have some counter that would start at 0, and there would be a person with a blue die, so they're the positive person, and a person with a red die, so they're the negative person. And the goal is for the negative person to get to -10, and the positive person's goal is to get to +10. So let's say the person with the red die rolled their die and they got a -4. And so I ask students to write the math problem down that they resulted. So the result would be 0 -4. Okay, so then you'd be here. All right, then the blue person goes, the positive person goes, and let's say they roll a 5. Okay, so this would be the resulting math problem. So they're moving up here 5 units, and they would, of course, the result would be to land on 1. All right, then it's the negative person's turn again. Okay, so they would be, so the answer here is 1. Negative person goes, say they roll a 3. Right, and so then the result, of course, would be, so then 3 back this way, so 1 plus -3 is -2. It's one of those games that can go on for a while because often you'll oscillate around the middle. Again, you know, if you're writing down the number sentences and you're seeing the model here, it's a fun way to present that. We've got our multiple representations with our concrete, along with our more abstract, right? This is the part of the lesson that is abstract. So for subtraction, as I mentioned with my 7th graders, this story problem was on the very first page that I gave them. And students did not have trouble telling me that this was -25, except if I wrote this as the number sentence, this is one of the most missed type of integer problems. All right, the answer to this, according to most students, is either 5 or -5. And I ended up calling these, and I would call this in terms of vocabulary words, I would call this a planned support, right? My planned support was that I came to the point where I referred to any problem in this form of like -a minus b. I started calling these the going more into debt problems. All right, because students were missing them all the time. And so this was the story problem that I always went back to. So that would be my planned support for helping students understand this problem. So again, students very intuitively got this answer before they had learned any of the rules about subtracting is add the opposite. I hadn't taught them any of that yet. So we're going to look at other ways to make sense of some of these subtraction problems. And then you're going to watch a second video on modeling these with the blue and red chips. So models for subtraction. So again, one of the problems that students tend to not have any trouble with is the idea that if you have 2 negatives right in a row, that the rule is, okay, 2 negatives in a row, minus minus means plus plus. And that becomes a rule that students very quickly memorize procedurally. The problem is sometimes they'll try to apply that rule up here. They'll say, oh, minus minus, plus plus, right? And they'll try to change -10 minus 15 to +10 plus 15, which I would try to say to them, would that even make sense? Right? Could -10 minus 15 be the same as +10 plus 15? You know, would that even make sense? But again, we tend to, I blame it on math teachers sometimes, myself included, we tend to teach kids that you memorize rules and they don't even have to make sense. So, you know, check your common sense at the door and just memorize these rules. So anyway, what I love to do to model a problem, this type of problem here with the minus minus, and students don't have a problem with procedural fluency with problems like this. Like I said, they very quickly learn to do minus minus is plus plus. All right, but to help them get conceptual understanding of this, I think the best way to do that is to show them on the thermometer. All right, and to show them that, here's 0, right? So when I start at 15, right, I go down to 0, but then from 0 to 8, that difference is 8, right? So the total amount of difference here is 23. Okay, so I have to add the 15 here and then count and then give this positive value, right? Because I'm still counting these positive 8 spaces. So moving on to the next page, and I don't know why, but when I sent this to the printer, my smartboard printer, I lost my number line. So I scribbled a little number line on here. So you're going to watch a video on how subtraction problems are modeled with the yellow and red chips. All right, but we're going to take a look at right now these 3 problems on the number line. All right, and I dubbed this the take a hike method, this first method up here. So that's not a universal term, right? The take a hike method. I did that because the textbook we used to use showed a little guy with like his backpack and walking stick. So that's why I called it that. But anyway, the take a hike method, if I were going to show the problem, so I'll do that right now. And this is where I would suggest different colored pencils, all right, so that you can model different problems on the same number line and follow which problem is which. So I'll model this one here in yellow. So you start facing forward. So here's my person and like there's their hair back here, okay? And a negative means walk backwards, and a positive means walk forward, and then a subtraction sign means turn around. So this example would mean walk forward 5. Okay, so I'd get here to 5, and I'm still facing forward, but then the negative sign means turn around. All right, so I turn around, and then the negative means walk backwards. So once I've turned around, I have to walk backwards 2, and I land on 7. All right, so let me switch colors and we'll take a look at a different example. So -4 minus -3. I'll do in red. Okay, so again, start at 0 facing forward. This time, walk backwards 4. Okay, I'm still facing this way. Since 4 was negative, I walked backwards. The negative sign means turn around. And then -3 means walk backwards 3. So I land here on +1. Okay, so you try the last one, -2 minus -7. All right, so you try that right now on your paper. Okay, I'm backwards 2. I turn around, right, and then I go backwards 7, taking me to 5. Okay, so the next method involving a number line, and again, I really like this for helping students get conceptual understanding of why minus minus is plus plus. All right, so I'm going to use, since I lost my number line anyway, when I went to a conference last fall, one of the elementary teachers used the term open number line. I said, what is open number line? And as soon as they showed me, I mean, it made sense and I really liked it. So as opposed to a number line that actually has numbers on it, an open number line, I just add whatever numbers I happen to need for the problem. So I'm going to use the open number line approach since I don't have my number line anyway. But what we're going to do is use the missing add-end approach. So if you can recall back in whole numbers, if we were doing a subtraction problem like this, and I wanted to use the missing add-end approach, remember I have my minuend and my subtrahend. The missing add-end meant that I started with the subtrahend, and then I said, what do I add to get up to my minuend? Okay, so we're going to use that approach here. I'm going to start with the subtrahend or second number, and I'm going to say, what do I add to -2 to get up to 7? Okay, so with the open number line approach, I just get to add whatever I want to my number line. And so I'm going to add a 0, and then I have to get up to 5. And so I am going to recognize that I move 2 units here, and then I move 5 units here. And one thing that we need to note when using this method is that right, actually let me wise up and use a text box. Text. Right is positive, left is negative when we move. Okay, so this is showing me that I am getting, so this would be 2 units here, 5 units here. So I have a total, I have counted up 7 units, right, to get from here to here. All right, so you try that on, well, I'll do one more with you, and then you can try the last one. So I'm kind of running out of room. I'm just going to open a new page. So I'm doing the problem -4 minus -3. So I start at -3 and I say, what do I need to add to get up to -4? In other words, what's the difference between -3 and -4 on the number line? Okay, so here's -3. Well, if I want to get to -4, there's only a difference of 1, and I've gone 1 in the direction, this direction here to the left. All right, so that is showing me that I need a -1, all right, because I've gone left. So you go ahead and try the last one on your own. The -2 minus 7. So try that one. All right, and the answer is +5. So next, I am going to send you to the YouTube video where you learn how to subtract integers using the yellow and red chips, and then we'll meet again.